So again, this is next tutorial the next tutorial which I'll be solving, and this tutorial is related to the node analysis. So I'll be solving a problem using the node analysis, or also known as by the node voltage method. So we will see how to apply the node voltage method. So this is my problem, and the question is to find the value of the current I. So this is my current I. So the first step in applying, so this is, you can apply the node voltage method in different, or node voltage method to solve the problem in different method, but this is one way through which I will solve the problem, and you can find it useful. So the same problem could be solved using even the node voltage method different ways, or in different books, or in different colleges or lectures which you are attending in your school, college, etc. So the first step is to identify the nodes. So the node will be a point where two or more elements are meeting. So I will say that this is a node for me. So this is a node 1, and I am saying that the node voltage is V1 here, and this is a node 2, so the voltage is V2 here, and this is a node 3 which the voltage is V3. So I have found out, so the V3 voltage will be 0 because it's a ground node, and I have identified two nodes. And for each of the, so first step is identifying the nodes. So I have identified 3 nodes in this case, and the second step is to identify the branch current. So when I'm identifying the branch current, I'm saying that this current is I1, and this current flowing through this branch is I2, and this current is I3, and this current is I4. So the second step, I have identified the branch current. Next third step, what I will do is I will apply the KCl. So when I am applying the KCl, I will get the equation of the at the nodes. So apply the KCl at the node. So I will apply the KCl at the two nodes here, because the third node is the ground node, and when I'm applying it, I will get I1 equal to I2 plus I, and the other equation which I will get is I equal to I3 plus I4. This was at the node 1, and this was at the node 2. And now the step 4 is to write the branch current in the form of node voltages. So when I'm writing the branch current in form of node voltages, what I will get is, for I, which is the current which I want to find, this is the question, is to find the current I. So for I will get it as the voltage difference between the two nodes. So I can take it any node to be at the higher potential. If I am wrong, I will get the direction of the current as negative. So my assumed direction is wrong. So this current is flowing in this direction, so it is always assumed that it is flowing from a higher potential to the lower potential. So the higher potential in this case is V1, and the lower potential is in this case is V2. So I will write it is V1 minus V2 divided by the resistance, that is 10. So that was my equation of I. Again, if I write the same way for all the different branches, then I will get I2 as V2 by 2, I will get I3 as V2, or I2 as V1 by 2, and I2 as V1 by 4, and again I will get I1 equal to 25 minus V1 divided by 5, but 25 I am taking is because this is at a higher potential, so the current is flowing this way. And again for I4, it will be v2 minus 50 divided by 2. So in this way I have got the equation of each of the currents in form of the node voltages, and after that the fifth step is to find out the two equations. So this was my first equation and this was my second equation of the KCl. So make the KCl equation in form of node voltages. So when I am doing that, I will have to substitute the value of the I currents here with the node voltage. So when I'm doing this for the first equation, which can be done very simply, like I1 I will have to take from here, which is 25 minus V1 divided by 5, equal to I2 from here, that is V1 by 2, plus I, which is equal to V1 minus V2 by 10. This becomes my first equation, and the second equation is for this case. So again my I becomes V1 minus V2 divided by 10, equal to I3 becomes V2 by 4, and this is plus I4 is V2 minus 50 by 2. So this becomes my second equation. So now I will have to solve these two equations. I will have to simplify this, which I have already done that simplification, and when I'm doing that, what I'm getting is 2v1 equal to 2v1 minus 6v2 minus 100 equal to 0. This is for this equation which I am getting, and for this what I am getting is so from this I will get the value of V1, and I will have to substitute this in this equation. And for the second case, what I will get is, I will get V1 equal to 3v2 plus 50. So I have got this will become my third equation, or this could become my fourth equation. And now I have two equations, and from this I will have to find out the value of V1 and V2. So I will from this, if I get the value of V2, I will have to substitute it in this equation, and that's a simple way to do that. Will be like, from this what I will get is my V2 is equal to 2V1 minus 50, and if I'm substituting it here, I will get V1 is equal to 3 into 2V1 minus 50 plus 50, and simplifying this further, so the next step is further solving this equation, and there was just an error. So solving this equation, what you will get is this, and solving this equation, what you will get is this. So to solve that in detail, I will have to just erase whatever I am doing, and I will have to show you that how this is solved. So it's very simple algebraic or mathematical operation, so if you are familiar with that, you can just skip that. But to show in detail, it's very simple. So the first equation which you got was something like 25 minus v1 by minus 5 equal to v1 minus v2 divided by 10 plus v1 by 2. So if you are solving this, so you will have to take the algebraic calculations here, and so this will come something like 25 minus v1 divided by 5 equal to, again if you are doing this calculation, then it will be 2v1 minus v2. If you want to multiply it here, it will become 10v1, and here it will become 20, and again this will cancel as 5 fours are, and this will, again you can take the 2 common here, so this will become 5 here, and this is 2 ones are, so this is 2 twos are, so this, if you are solving, it will become 50. Minus 2v1 is equal to v1 minus v2 plus 5v1. So this full will become 50 is equal to, if you are taking this v1 here, then this total will become the 8v1 minus v2. So this is the first equation which we have simplified, and based on that you can get the value of the v1 or v2 as, if you are finding it, so anyway you can do it. So you can find the v2 as 8v1 minus 50. So this is what you have, how you have solved the first equation, and now you have the second equation, and how you will solve that is, the second equation is v1 minus v2 divided by 10 is equal to v2 by 4 plus v2 minus 50 by 2. So again you are simplifying that, so it will remain v1 minus v2 by 10 is equal to 2v2 plus 4 into v2 minus 50 divided by 8. So again you can take a 2 common, so what you will be remaining is v1 minus v2 divided by 10 is equal to v2 plus 2 v2 minus 50 divided by 4. So if you are simplifying that, and this will cancel as 5 twos are and 2 twos are, so it will be 2v1 minus 2v2 if you are multiplying it this way and this way, equal to 5v2 plus 10v2 minus 100 or minus 500. So when you are simplifying this full thing, what you will get is 2v1 is equal to 17 v2 minus 500. Now you have got this as your second equation, and this is your first equation by solving the first equation. So this could be, you can name it as any, like a third equation or a fourth equation, whatever sequence you are going on. But now the next step is substituting the v2 here. So when you are doing that, you will solve and you will get your as 2v1 equal to 17 into 8v1 minus 50 minus 500 equal to 0, and when you are solving for that, you will get v1 is equal to 10. And once you have got your v1, you know v1 minus v2 divided by 10 was your I, and if you are substituting your v2 here in this equation, you will get your v2 as v2 is equal to 8 into 10 minus 50, which is equal to 80, which is equal to 80 minus 50 equal to 30. So you got your v1 is equal to 10 and you got your v2 is equal to 30, and the I equal to V1 minus V2 divided by 10 equal to 10 minus 30 divided by 10. So your I is equal to minus 2 ampere. So I will just save this and erase this to show what we have found so far. What we have found so far is that we have found that V1 is equal to 10 and we have found V2 equal to 30 and I equal to V1 minus V2 divided by 2 divided by 10. So your I you got was 10 minus 20 divided by 10 is equal to minus 2 amperes. So the minus just suggested that whatever direction for the current which you have taken is wrong, and so the value is opposite in actual. So again you can find your I1 as 25 minus V1 which is 10 divided by 5 equal to 3 amperes, and your I2 is 5 amperes and your I3 is 15 amperes based on the equations which you have written previously, and your I4 is equal to V2 minus 50 divided by 2, which comes across as 30 minus 50 divided by 2 is equal to minus 10 ampere. So again this was all the equations. So again, to cross validate, what was your KCL was is equal to I1 was equal to I plus I2. So this was your first equation of the KCL which you had previously written. To just validate whatever we have calculated so far is correct, you can put up in this KCL equation and you can find your I1 as what you have got for I1 is 3 amperes. So 3 equal to I, which is your minus 2, plus I2 which is equal to 5 amperes. So this is I2, so equal to 5 amperes. So this is equal to 3. So whatever you have calculated so far is correct and it has been validated or cross checked. So in this way it is also possible to cross check your answer. So this has been a long problem, and this is a full step to step how you can apply or solve a problem using node voltage or voltage method. So there might be different methods to even solve this using the node voltage method, but this is a step by step which I found useful and I have just shown. So it is also possible to solve the same problem using a loop analysis or branch current method, or even using mesh analysis. So it's possible to solve the same problem using the multiple ways, but sometimes in question it will be specifically asked to solve the problem using a node voltage method, and if you are looking to find out about node voltage method, you have found out you could have found out this video useful. Also to watch the other videos to learn more about engineering, electrical engineering, etc.